Okay, let's get started with our first section. You'll probably see that in the first couple of sections, a lot of this is review from some previous math courses that you've taken in the past, whether it be high school or maybe also in college. So let's just review some of the basics before we actually get started with section 2.1. And some of the basics that we have to constantly recall upon, one of them is called the distribution property. Now, the distribution property, that's technically a nickname for it. If I was to give you the formal full name, it would be the distribution property of multiplication over addition and subtraction. And basically, the distribution property tells us that if we have A times B plus or minus C, that we could actually distribute the multiplication. There's an understood multiplication here, and we can distribute that A and multiply it with the B and with the C, in which case we would have AB plus or minus AC. And of course, we know AB means A times B, AC would mean A times C. Okay, and the plus and the minus sign, that stays the same. And that's the distribution property, whereby we can distribute a number that's on the outside over the terms that are on the inside. For example, if we had maybe 3 times 5x plus 2, we would distribute the multiplication of 3 with the 5x and with the 2. And of course, 3 times 5x would give us a 15x, plus 3 times 2 would be 6. And that would be using the distribution property. Another common thing that we need to do is to combine like terms. Now, what's meant by like terms? Okay, in order for terms to be considered like terms, they need to have the same variable as well as the same exponent. For example, like terms might be 5x, 7x, negative 3x. Those are 3 like terms. Or if we had 7x squared, 2x squared, and a negative 8x squared. These are also considered like terms. Once again, by definition, they need to have the same variable, which these do all x. These do all have an x as well. But they also have to have the same like terms, the same exponent. So these 3 terms all have an exponent of 1, an understood 1. And these 3 are also considered like terms because they all have the exponent of the squared. Okay? So when we want to combine like terms, for example, if I had, let's say, a 4x plus, let's say, 9x, we would want to be able to combine these. They have the same variable as well as the same exponent. We would want to combine this into a 13x. Basically, you take the 4 and the 9 and you add them together. Okay? If we had, let's say, a 5x squared minus a 3x squared, we too would want to combine these because they have the same variable and the same exponent, and we can combine them. We take the 5 and the 3, and we would have to subtract them. 5 minus 3 would give us a 2x squared. Notice the variables just come along for the ride. The only thing that we add or subtract when we combine like terms is the numbers that are in front. Now you may recall that number 4, 9, 5, and 3. Those numbers have a special name. It's called the coefficient. Okay? So basically when you combine like terms, you're going to add and subtract the coefficients. The variables and the exponents just come along for the ride. So the distribution property and the combining of like terms are very important, okay? And we're going to need them for our section 2.1. Because in section 2.1, it'll be about all about solving what we call linear equations. Now, when we solve an equation, we're basically trying to find out what the variable x represents, okay? And you've seen this probably before. It's been a while maybe, so let's just review some of the basics. When you solve a linear equation, I am going to suggest that you go through 4 simple steps, okay? You don't necessarily have to go the steps in order. Okay, so let's take a look at what those 4 steps are to solving a linear equation. Well, step 1, what we want to do is we want to simplify both sides of the equation. That's very important. And I'm going to tell you how we're going to simplify both sides of the equation. We could do one of 2 things. We could either use the distribution property, or we can combine like terms. Those are the 2 things that we're going to do when we want to simplify both sides of the equation. We're going to either use the distribution property and or we are going to combine like terms. After we complete step 1, we're going to do step 2. Step 2 tells us that we want to get the variable on one side of the equation. Because sometimes the variable might be on both sides of the equation. And we want to, in step 2, we want to get the variable on one side of the equation. And it doesn't make a difference which side of the equation you put it on. Some people put it on the right side, some people put it on the left. I usually try to get my variable on the left side of the equation. And how are we going to do that? Well, we're going to either add or subtract. Those are our only 2 options when we're trying to get the variable on one side of the equation. Okay? Step 3. In step 3, what we want to do is we are looking to now eliminate the constant. Okay? When we are talking about eliminating the constant, that is the number that is not part of the variable. That's the number that's hanging out all by itself. And we want to try to eliminate the constant. And how are we going to do that? Well, once again, we could do one of 2 things. We could either add or subtract. Those are our only 2 options when we are trying to eliminate the constant. Finally, now in step 4, we want to now, in step 4, eliminate what we call the coefficient. Now, I've mentioned that word before. The coefficient is the number that's in front of the variable. Okay? If we were to go back up to the original problems, we had coefficients of 4, 9, 5, and of course the -3. Those are the coefficients that we are looking to eliminate. That will help us solve for the variable. And how are we going to do that? Well, we could do one of 2 things. We could either multiply or we can divide. Those are our only 2 options. So basically what I gave you here are 4 suggested steps to solving a linear equation. And basically I told you how we're going to do that. So let's just review. First, we simplify both sides of the equation. And how do we do that? We're going to use either the distribution property and or combine like terms. Step 2, if the variable is on both sides of the equation, I'm going to strongly suggest that you get the variable on one side of the equation. And how do we achieve that? We're going to either add or subtract. Next, in step 3, we're going to eliminate the constant. That's the number that's hanging out all by itself without a variable. And how do we eliminate a constant? Well, we're going to once again add or subtract. Those are the only 2 options. Finally, should we try to now do our fourth and final step, whereby we try to eliminate the coefficient. That's, of course, the number that's in front of the variable, attached to the variable. And how do we achieve that? We're going to either multiply or divide. Those are our only choices. Okay? So let's try some examples. Let's start off with some basics, and let's build upon those, and let's just see what we recall about solving what we call linear equations. So the directions would be simple. It, of course, would say solve for, I'm going to use the variable x. Okay? So we're trying to solve the mystery, what is the numerical value for that variable x. And let's see what we can do. Let's say, for example, we have the following. 4 times x plus 5 is going to equal 2 times x minus 5. Now, as we go through our steps, once again, we don't have to go through them in any particular order. I'm going to follow the order that I laid out for you. Not every step needs to be done. Here, we're going to start with step 1, because step 1 could actually be performed. Whenever you see these large parentheses and a number outside, here we have the number 4, and on the right side of the equation we have the number 2. And when we have something like this, we're going to need to use that distribution property. So let me start by distributing the 4 on those two terms, and distributing the multiplication of 2 on these two terms, and that would now give us a 4x plus 20 equaling a 2x minus 10. Okay, if you need assistance with the multiplication aspect, remember you can use a scientific calculator. So step 1 is done. Step 2, we see that we have the variable x on both sides of the equation. We don't want that. So we are trying to get the variable x on one side. And like I said before, I like to put my variable usually on the left side. So since we have a 2x here, I could do one of two things. I could either add or subtract. Well, to get this variable x onto the left side, I'm going to have to subtract 2x from both sides. Remember, what we do to one side of an equation, we must always do to the other. Now, what would that leave us with? Here on the left side, 4x and a negative 2x, that would produce a 2x plus 20. On the right side, 2x and the negative 2x cancels, leaving us with a minus 10. Always be very careful of your signs. So now step 2 is done, in that we have the variable on one side. Next, we're going to eliminate the constant. Here the constant is 20. Since it's already being added, we're looking to do the opposite to eliminate that constant. So once again, we can either add or subtract. So I'm going to subtract 20 over on both sides. Now on the left side, the 20 minus 20, that simplifies, leaving us now with just a 2x on the left. Negative 10 minus 20 is a negative 30 on the right. And so now we're up to step 4. We want to eliminate the coefficient. We could either multiply or divide. Since the 2 is being multiplied with the x, we're going to do the opposite. I'm going to divide both sides by 2. 2 divided by 2 on the left side would leave us with simply the number variable x. And negative 30 divided by 2 would, of course, give us a negative 15. And that would be your solution. So we got a negative 15 as our solution for the variable x. Okay? That was the first one. Let's try one that's a bit more complicated. For example, same directions, solve, of course, for x. And let's say now we have 2x minus 5 times x minus 2 equaling 20 minus 2 times x plus 3. Okay. Once again, we want to solve for x, and I'm going to say we perform step 1 first, and that we want to simplify both sides of the equation. Let's start by looking at the left side. On my left, I can distribute this negative 5. On the right, I can distribute the negative 2. And in doing so, we would now have a 2x minus 5x plus 10 equals 20 minus 2x minus 6. Okay, I distributed the negative 5. Watch your signs. I distributed the negative 2. Also watch your signs. We're not done with step 1 because we could still simplify both the left and the right side. On my left side, I have like terms, 2x minus 5x. Let's combine those like terms. And when we do, we get a negative 3x plus 10. On the right side, we also have like terms. We have the 20, as well as we have the minus 6. Those are also like terms. 20 minus 6 would give us a 14 minus 2x. And now step 1 is done. So let's move on to step 2. Step 2, we are looking to get the variable on one side. And right now the variable is on both. So once again, I'm going to put my variable here on the left side. I need to eliminate this subtracting of 2x. So I'm going to do the opposite. I'm going to add a 2x on both sides of the equation. Here on my left, a negative 3x plus 2x. That would give us a negative 1x plus 10 equals, here on the right, we're going to have simply the number 14. And so now we have gotten the variable on one side. So step 2 is complete. Step 3, let's eliminate the constant. The constant is the 10. And since it's already being added, we have to do the opposite. So I'm going to subtract 10 on both sides. That would leave us now with a negative 1x on the left and a positive 4 on the right. But remember, to answer the question, we want to solve for x, 1x. Right now we have a negative 1 times x. So we do have to perform step 4. We want to eliminate the coefficient of negative 1, so I'm going to divide both sides by a negative 1. Here on the left, negative 1x divided by a negative 1 is 1x. On the right, 4 divided by a negative 1 would give you a negative 4 as your solution. Okay? So there we had to do a bit more work, particularly in step 1, where we had to not only use the distribution property, but we also had to, of course, combine like terms. Okay? Let's try another one. Maybe I'm going to have you try one on your own. All right? I'm going to write a problem down, and then I would ask that you pause the video, try to work through the problem and see what you get for your solution. Once you have worked through the solution, turn the video back on and let's see if you get the same answer as me. So here comes the problem. Let's say we have 4 times x minus 3 equals 6 times x minus 2. So take a moment now, pause the video, work through the problem on your own, and see how you make out. When you're done, once you have your solution, turn the video back on and we'll work through the problem together. Okay, let's start with step 1. In step 1, I'm going to have to distribute my 4, and I will also have to distribute my 6. Here on my left side, I would get a 4x minus 12 equals, when I distribute on the right side of the equation, that would produce a 6x minus 12. Step 1 is done. Let's now move on to, of course, step 2. Step 2, I'm going to get my variable on one side of the equation. I will subtract the 6x over. When I do that, on my left side, I am left with a negative 2x minus 12 equals a negative 12. Okay. Now, step 2 is done. We have our variable on one side. So now we are up to step 3, whereby we want to eliminate the constant. The constant here is the 12, which is being subtracted on the left side. So to eliminate this 12 that's being subtracted, I'm going to add the 12 over onto the right. Negative 12 plus 12 on the left side would leave us with a negative 2x. On our right side of the equation, negative 12 plus 12, the number 0. And so now we're up to step 4. We want to eliminate the negative 2. That's the coefficient. So I divide both sides by negative 2. And when we do that, we're left with x equaling 0. 0 divided by any number will always simplify to 0. And that is your solution. Sometimes people panic when they get a solution of 0. They don't like a solution of 0. And it's perfectly fine to have a solution of 0. Okay? If you have a solution of 0, that's your numerical value. Okay? Let's try another one. Let's say we have the following. 5 times 2x minus 1 equaling 12x minus 4. Okay, let's solve this one together. I'll start with distributing my 5 on these two terms, producing a 10x minus 5 equaling 12x minus 4. Step 1 is done. Step 2, let's get that variable on one side. I am going to subtract the 12x over. 10x minus the 12x would leave us with a negative 2x minus 5 equaling, on the right side, 12x minus 12x. That cancels, leaving us with a simple negative 4. Now we're up to step 3. We want to eliminate this constant of 5. Since it's being subtracted, let's do the opposite. Let's add 5 over. In which case now, on the left we still have the negative 2x, and on the right we have the number 1. Now remember, we're up to step 4. Step 4 tells us we have to eliminate this coefficient of negative 2, okay, which is being multiplied with the x, so we will have to divide both sides by the negative 2. Here on the left side, we're left with just x, and on the right, we are left with a fraction of negative 1/2. Now don't panic if your answer is a fraction, as sometimes people do. I know people have a phobia of fractions about them for whatever reason, but we have just demonstrated here that you can get all different kinds of solutions. In our very first problem, we got a negative 15. In our third problem, we see here that it's possible to get 0 as a solution. And we see here in the fourth example that it's even possible to get a fraction as an answer. Okay? So answers can take many different forms. Okay? Just because you get 0 or just because you get a fraction, don't panic. Don't feel that you must have done something wrong. Okay. I want to take a look at two very special cases. Okay? For example, let's say we have the following. 2 times x plus 1 minus 3 times x minus 1 equaling 5 minus x. Once again, we want to go through our 4 steps to solving. And now let's take a look. On my left side, I have a lot that I can do here. All right. First of all, I'm going to use my distribution property. I will distribute the 2, and I will distribute the negative 3. And in doing so, it would produce 2x plus 2 minus 3x plus 3, equaling now on the right side still 5 minus x. We're not done with step 1 because on the left side we have like terms. Let's take a look. I have a 2x and a minus 3x. Those are like terms, and I get a negative 1x. And I also have the positive 2 and the positive 3. And when I combine those like terms, we get a plus 5 equals the right side 5 minus x. So step 1 is done. Now I'm going to go to step 2, and this is where something unique and special is going to happen. I need to get the variable on one side. And so I am going to add the x that's on the right side, and I'm also going to add it to the left side as well. Now here, negative 1x plus x, that cancels, and I'm left with a 5 on the left. On the right side, the negative x and the plus x also cancels, and I'm left with also the number 5. Now the directions, had I written them, we're going to say solve, of course, for the variable x. But in looking at the equation that we are left with, the variable x that was originally in the problem is gone. Okay, this is one of those unique cases. If the variable, after you perform step 2, if the variable that you are solving for is no longer found in the problem, you have to look at the statement that's left. Now, the statement that is left, 5 equals 5, that is a true statement. And when you are left with a true statement like this, that 5 equals 5, what we say is x is all real numbers. That would be your solution. That means every number, every real number, if I substitute it in for x on the left side and the right side, it would make my equation true. Whether I plug in a positive 5, whether I substitute in a negative 3, maybe if I substitute in 0, if you want to be, courageous a little bit, you might want to substitute in a fraction number, okay? And no matter what number you substitute into this equation, all real numbers would make this equation true, which is quite the opposite of the first 3 examples that we did. In the first 3 or 4 examples that we did, we found one unique number, and only that number would work. But for a problem like this, where the variable canceled out that you were solving for, and you were left with a true statement, that's when we write all real numbers. That's one special case. Let's take a look at a second special case, okay, and see what kind of answer we're going to get. For example, 6 times 3x minus 1 is equal to 2 times 9x plus 4. Let's solve for x, and let's see what's going to happen here. For starters, once again, we're going to perform step 1, in that I will distribute my 6. On the left and on the right, I will distribute my 2. Let's see what's going to happen. When I distribute on the left side, we get 18x minus 6 equals, when we distribute on the right side, we would get 18x plus 8. Okay, step 1 is done. Now let's go on to step 2. In step 2, we have to get the variable on one side. So I'm going to subtract 18x over on both sides. When I do that, we're left with a negative 6 on the left, and on the right, I am left with the positive 8. Now, let's take a look at what's happening here. Because once again, after we performed step 2, the variable that we were solving for is no longer found within the equation, okay? But unlike in the previous example, where 5 equaled 5, we were left with a true statement. Here we are told that negative 6 equals 8. We didn't do anything wrong. However, we are left with a statement that is, of course, false. And when you are left with a false statement, I don't care what the statement is, okay? If the statement is false, that's when we would write no solution. That would be your answer. There is no known real number that will make this equation true. Okay, so it is possible to have all different kinds of solutions when solving linear equations. You're looking for one special unique number. That number can be positive, it can be negative, it could be 0, or it could be a fraction. Should the variable that you're solving for goes away and you're left with a true statement, that's when you know x is all real numbers. Okay? Should the variable that you are solving for goes away and you're left with a false statement, that's when you say hold everything, no solution here. Okay? Those are the different types of solutions that you can achieve. Now, before we go, I do want to address how to solve equations that involve everybody's favorite fractions. Okay? For example, let's say we have 2/9 x minus 1/2 equals 1/18 x plus 2/3. Now, most people look at this type of a problem and they panic because, for whatever reason, people have a phobia of fractions. They just don't like them. Okay? But I'm going to try to help you get through that phobia, okay, because we will encounter many fractions during the course of the semester. And so what we're going to try to do here is, if a problem like this makes you nervous, what we're going to try to do is we're going to try to clear the fractions. We want to get rid of all of those nasty looking fractions. And the way we're going to do that is we're going to identify what we call the lowest common denominator. Let's look at the denominators for a moment. 9, 2, 18, and 3. We are looking for the smallest number that is divisible by 9, 2, 18, and 3. Okay? What number that if I divide them by 9, 2, 18, and 3, will it go in evenly? And of course the answer is 18. 18 is the smallest number because 18 is divisible by those 4 denominators. There are larger numbers, but I'm going to recommend that you get the smallest number possible. So now what we have to do to clear the fractions is we're going to multiply all 4 fractions with the number 18. And this is where your calculator may come in handy. On your calculator, you may notice an A, B, C key. Or some calculators have an N over D key. That is your fraction key. Okay? So this key, either one, will help you with working with numerical fractions. Okay? And you want to be familiar with how to use your calculator. So if we were to multiply the 18 with the 2/9, okay, 2/9 times 18 would leave us with a 4x minus. Next we have to multiply the 18 with the 1/2, and half of 18 would give us the number 9 equals. Now we have to multiply the 18 with the 1 over 18, and that of course would give us 1x. And lastly, we're going to multiply 2/3 times the 18, and that would give us the whole number 12. So what we have done, we have cleared all of those fractions, making it an easier type of an equation for us to solve. Okay? We didn't change the overall relationship. All we did was clear out all of those nasty kind of fractions. So now we're going to proceed like we did prior. We don't have to worry about step 1. because there's nothing to distribute anymore, and there are no like terms to combine on either side. So we move on to step 2. Let's get the variable on one side. I'll subtract the 1x over, leaving me with a 3x on the left minus 9 equals the positive 12. When, of course, now we have to go on to step 3, where we want to eliminate that constant 9, I'm going to add the 9 over, giving us now 3x equals 21. And so now here we are in step 4, where we have to eliminate the coefficient. I'm going to divide both sides by the number 3, leaving us now with x equals the number 7. Okay, so that is a process of how we can eliminate all of the nasty fractions that we may sometimes find in our equations. So hopefully with some practice, you'll feel a little bit better about doing that. Okay, that completes section 2.1. And speaking of practice, there is, of course, some homework problems that go along with this section. I would suggest that you give them a try. And if you have any questions, feel free to email me. Okay? Until the next time, be well.